example 5, we're going to solve a rational inequality. We have 2x minus 7 over x minus 5 is less than or equal to 3. Then we're going to graph the solution set. So what we're going to do is we need to set it equal to 0. So let's do 2x minus 7 less than x minus 5. And then, we subtract 3 from both sides is less than or equal to 0. Let me go ahead and move that less than or equal to. So I'm going to put it over here. So in order to solve this, what we're going to have to do is get a common denominator. So we're going to multiply by x minus 5 to the top and bottom of negative 3. So this will become 2x minus 7 and then negative 3x plus 15 all over x minus 5. Then we simplify, so 2x minus 3x is negative x plus 8 over x minus 5. And when is that less than or equal to 0? So we need to look at our important values that are important in here. And so we know that x equals 5 is important. And we also know that x equals positive 8 is important here. So let's graph 5. And 5 we cannot have, right? Because that's in the denominator. So it's undefined at that point. So that's an open circle. And then 8 we could have because it says equal to. So therefore that is a solid circle. We know we can have that number. And then now we're going to test points to see where this is true. So let's see. Let's test a number in between. Let's test 6. So if I plug in 6, I get negative 6 plus 8 over 6 minus 5. And so that is going to be 2 over 1. And is that less than or equal to 0? No, it isn't. So that doesn't work. So let's test another value. Let's test to the right. So let's go ahead and test 10, positive 10. I'm going to plug it into here, see if it's true. So that's negative 10 plus 8. Over positive 10 minus 5. This becomes negative 2 over positive 5. Is that less than or equal to 0? Yes, that is true. So that we can have. Then on the left, let's choose my favorite, 0. So let's plug in 0. We get 8 over negative 5. And is that less than or equal to 0? Yes, that is true. So we have these points, and so 5 is a 0 of our denominator, and of course it's open circle again because it's undefined at that point. Then the other point that we need to mark is our 0 of our numerator, which is positive 8. We could have a 0 in the numerator, so that's fine, and especially since it tells it could be equal to. So this is our solution set here. We can say our solution is, I'm going to write it up here, solution set is from negative infinity to 5 parentheses, because we cannot include that 5, union, that should be a bracket, 8 to infinity. And so here's our solution. And then you have your graph as well. So go ahead and try this next example right up here. Actually, there's 2 of them to try. Pause the video, and when you come back, I'll have the answer for you. So with letter A, you would see after you multiplied, you would get 4x minus 11 over x minus 3. And when is that greater than or equal to 0? And so we put our important point at 3, open circle. That's where our denominator can't be 0. And then 11 over 4 is our 0 of our numerator. And so here we see that if you test it out 0, it does work. That's true. I tested out 4. And that also works as well. So our solution is negative infinity to 11/4, bracket, union 3 to infinity. For letter B, you would simplify that to x plus 17 over x minus 6. And when is that greater than 0? And so we put spots at negative 6, 17, and 6. And it's only greater than, so no closed circles here. We tested 0. 0 is a negative value. That's not greater than 0. So I tested negative 20. That is negative over negative, which is positive. So that works. And then I tested 7. That is also positive over positive. So that is also greater than 0. So our solution in this case is negative infinity, negative 17, union 6 to infinity. Now, the last thing we're going to do is we're going to take a look at finding the domain of an expression. So we're going to do that in this fashion where we use the linear inequality. So find the domain of square root of 64 minus 4x squared. And so we know that the radicand inside, whatever, well, that is the inside, the radicand must be greater than or equal to 0. So let's solve for that. 64 minus 4x squared, when is that greater than or equal to 0? Let's factor out a 4. This is 16 minus x squared, greater than or equal to 0. So this is 4 minus x times 4 plus x, and when is that greater than or equal to 0? Our zeros are at 4 and at negative 4. So we're going to do that on our inequality. So we have to draw one. We have negative 4 and 4, and we need to test where this inequality is true. So let's go ahead and test 0. If I plug in 0 here, I get 4 times 4 times 4. Is that greater than 0? Yep, that is true. And so we're allowed to get zeros in here. So these are actually closed circles. And so that is true there. Now, if I plugged in 5, what would happen if I plugged in 5? So 4 times 4 minus 5 times 4 plus 5, is that greater than or equal to 0? You know, this is positive, this is negative, and this is positive. And so this is not true, and the same would be true for negative 5. So in this case, in order to find our domain, the domain we see, it's between, and it's a bracket of negative 4 to 4. So go ahead and try this last example. Find the domain of x squared minus 7x plus 10. So it has to make it greater than or equal to 0, factor it, and do the test like you did before. Pause the video, try it out. Okay, if you tried this out, you set x squared minus 7x plus 10 to be greater than or equal to 0, factor it. So our zeros are at 5 and 2, or 2 and 5. Then you test each interval. So 0, that does work. So negative times negative is positive, so that's definitely greater than 0. I tested 3 in the center. I get a negative times a positive, so that doesn't work. Then I tested 6. That is definitely positive times a positive, which is greater than or equal to 0. So our solution set here is negative infinity to union 5 to infinity, and make sure you have the brackets in the right spot. Thanks for watching. Hope this helps.